Stop scrolling. Right now, at this exact second, you're hurtling through space at 67,000 miles per hour on a rock that's about to seem very, very small. You don't feel it. You can't see it. But beyond our atmosphere lies something that will make you feel impossibly tiny and absolutely mesmerized. And by the end of this video, you'll never look at the night sky the same way again. You might think our sun is massive, and in human terms it is. Its radius spans 700,000 kilometers, 430,000 miles. Imagine driving from New York to Los Angeles 200 times. That's the sun's diameter. Or for my UK viewers, picture the distance from London to Edinburgh, repeated over 400 times. That's how wide our star truly is. Even if you combine the mass of every planet in our solar system, the sun would still outweigh them 743 times over. It is the gravitational anchor of our cosmic neighborhood, the engine of life itself. But here's the twist. In the grand hierarchy of stars, our sun is painfully ordinary. Astronomers use something called the Hertzsprung-Russell diagram. Think of it as the family tree of stars. It maps them by brightness and temperature. Running through its center is the main sequence, the cosmic backbone where most stars spend their lives. Here, stars exist in a delicate balance, a cosmic tug-of-war between gravity pulling inward and energy pushing outward. Our sun sits comfortably in the middle, a middle-aged, medium-sized star, perfectly average, perfectly special. Every second, it fuses 600 million tons of hydrogen, releasing the energy that has sustained life on Earth for billions of years. But wait here, that's where it gets wild. Everything we just discussed. That's child's play compared to what's coming. Take Bellatrix, the blazing left shoulder of Orion. It burns at a scorching 22,000 Kelvin, so hot its surface would vaporize any spacecraft instantly. It's 8.6 times more massive, and its volume is 200 times greater. In the time it took you to hear this sentence, Bellatrix consumed enough fuel to power Earth for 500 years. Remember Earth. That vast planet we started with. Bellatrix could swallow 200 of them without breaking a sweat. Yet this magnificence comes at a cost. While our sun will live for 10 billion years, Bellatrix has only a fleeting existence. It has already burned for 25 million years and has just 7 million left. In cosmic terms, it is a mayfly, dazzling, powerful, but tragically short-lived. This is the paradox of cosmic giants. Brilliance always demands a price. Bellatrix burns bright and dies young. But what if I told you there's a star so unstable it could explode tomorrow? And when it does, the blast will be visible from Earth in broad daylight. A star that rewrites everything we thought we knew. That's next. Bellatrix burns bright and dies young. But what if I told you there's a star so unstable it could explode tomorrow? And when it does, the blast might be visible from Earth in broad daylight. Welcome to the realm of the universe's true monsters. Astronomers believe stars can't grow much bigger than about 150 times the mass of our sun. Beyond that, they become so unstable that they tear themselves apart. But the universe, in its infinite creativity, has found ways to cheat. When two massive stars collide and merge, the result is a behemoth far larger than anything possible through slow accretion. And it's here we meet one of the most staggering discoveries ever made, R136A1. Forget the 150 mass limit. R136A1 has been estimated at 265 times the mass of our sun and a radius 40 times larger. It belongs to a rare, violent class known as Wolf-Rayet stars. How rare? In our entire galaxy, we've only found about 220 of them. Scientists suspect there could be as many as 2,000, but even that makes them cosmic unicorns. Wolf-Rayet stars are unstable, short-lived, and furious. They hurl plasma into space at 3,000 kilometers per second, 1,860 miles per second, ejecting as much as 10 solar masses every million years. Imagine entire suns being blown away like dust in the wind. And the light, R136A1, releases as much energy in 4 seconds as our sun produces in an entire year. To our eyes, it's only 164,000 times brighter than the sun because most of its radiation is ultraviolet. Still, it's a cosmic lighthouse, burning with impossible intensity. But here's the twist. R136A1 isn't even the largest star by size. It's one of the most massive, yes, but when it comes to sheer radius, other stars dwarf it. So far, we've focused on stars in their stable, hydrogen-burning phase. But what happens when that fuel runs out? Gravity takes over, crushing the core, raising the temperature and igniting helium fusion. This process heats the outer shells, causing hydrogen in those layers to fuse as well. The result? The star swells into a red giant. Our own sun, with its current radius of 700,000 kilometers, 430,000 miles, will one day expand to a diameter of 300 million kilometers, 186 million miles. That's big enough to consume Mercury, Venus, and possibly Earth. A living example of this transformation is Mira A in the Cetus constellation. It's only about the same mass as our sun, yet its radius is 332 times larger, and it pulses, swelling and shrinking over cycles of 80 to 1,000 days. At maximum, it can reach 402 times the sun's size. Think about that. A star barely heavier than our sun, yet hundreds of times larger. It's proof that mass isn't the only path to gigantism. Remember that fragile speck we started with, Earth, racing through space? Mira A could swallow our planet whole and still have room for hundreds more. But even Mira A isn't the biggest. Because when stars reach about 8 solar masses, they enter a new, terrifying category, the red supergiants. Take Betelgeuse, the fiery shoulder of Orion. Its diameter is 1.2 billion kilometers, 746 million miles, more than 700 times the size of our sun. If Betelgeuse sat at the center of our solar system, Mercury, Venus, Earth, Mars, and even Jupiter would all be engulfed. Betelgeuse is unstable, pulsing violently, throwing out material, blurring the line between star and space. And one day soon, it will explode in a supernova so bright it will outshine the full moon. Betelgeuse is vast, but it's not the largest, because hidden in the constellation Scutum lurks a star so colossal, so incomprehensibly huge, that 5 billion suns could fit inside it. In Part 3, we'll meet UY Scuti, the current record holder for the largest known star, and explore how these giants live, die, and seed the universe with the very elements that make us who we are. Betelgeuse is vast, but it's not the largest, because hidden in the constellation Scutum lurks a star so colossal, so incomprehensibly huge, that 5 billion suns could fit inside it. This is UY Scuti, the current record holder for the largest known star. UY Scuti is a red supergiant, glowing a deep, somber red. It's cooler than our sun, about 40% less hot, yet its sheer size makes it a cosmic titan. Its radius is so immense that if placed at the center of our solar system, it would engulf Mercury, Venus, Earth, Mars, and even Jupiter. But here's the catch. UY Scuti isn't visible to the naked eye. At 5,000,000 light-years away, you'd need powerful binoculars or a telescope to glimpse it. And even then, its true size is uncertain. Astronomers debate whether it's the largest star we've ever found or if others might rival it. But wait, UY Scuti won't stay this way forever. In fact, it's already nearing the end of its life. UY Scuti is between 10–20 million years old and may only have a few million years left. Soon, it will shed its outer layers, shrinking into a yellow hypergiant. These stars are brighter, hotter, and far more unstable. Hypergiants are capable of ejecting the mass of Jupiter in a single explosive burp. Their violent expulsions create vast clouds of gas and dust, sometimes stretching 10,000 astronomical units. That's 300 times the distance from the Sun to Neptune. And here's the poetic twist. Those clouds, filled with heavy elements like carbon, oxygen, and nitrogen, become the raw ingredients for new stars, planets, and even life itself. The death of giants seeds the birth of worlds. Remember that fragile speck we started with. The very atoms in your body, the oxygen you breathe, the carbon in your cells, were forged in the fiery deaths of stars like UY Scuti. You are, quite literally, made of stardust. UY Scuti isn't alone. In the Large Magellanic Cloud, 160,000 light-years away, lies WOHG 64, another red supergiant. It may already be transforming into a yellow hypergiant, dimming as it throws off material and becomes shrouded in dust. The problem? At these distances, measurements are uncertain. Maybe WOHG 64 is even larger than UY Scuti. We simply don't know. There's a theoretical boundary called the Hayashi limit, the maximum size a star can reach given its mass. If a star crosses this line, convection takes over, gravity wins, and the star shrinks. That means UY Scuti and its cousins are scraping against the edge of possibility. Perhaps one day we'll find a star slightly larger, but not by much. Unless, of course, there's a type of giant star we simply haven't discovered yet. And here's the humbling truth. Even these monsters are tiny compared to the universe itself. Galaxies stretch tens of thousands of light-years across. Cosmic filaments span billions of light-years. Against that backdrop, even UY Scuti, the largest known star, is just a speck. The universe is so vast we can't begin to pretend to understand it all. But that doesn't mean we can't try. And maybe, just maybe, living on a small planet orbiting an average star is exactly what makes our existence so precious. We've met the giants, stars so big they defy imagination. But their deaths are even more spectacular. In Part 4, we'll witness the final act: supernova explosions, collapsing cores, and the birth of black holes and neutron stars. And in that destruction lies the ultimate paradox, the seeds of creation itself. We've met the giants, stars so vast they defy imagination, but their endings are even more spectacular. Because when a star like Betelgeuse or UY Scuti reaches the end of its life, it doesn't simply fade away. It erupts in a cataclysm so violent, so awe-inspiring, that it reshapes the universe itself. When a massive star exhausts its fuel, gravity takes over. The core collapses in milliseconds, temperatures soar, and the star detonates in a supernova explosion. The energy released is staggering. In a single moment, a supernova can outshine an entire galaxy of billions of stars. If Betelgeuse were to explode tomorrow, it would be visible from Earth in broad daylight, brighter than the full moon. But this destruction is not the end. It's the beginning of something new. Sometimes, the collapsed core stabilizes into a neutron star. Imagine cramming the mass of our Sun into a sphere barely 12 miles, 20 kilometers wide. A teaspoon of neutron star material would weigh 1 billion tons. These remnants spin at dizzying speeds, emitting beams of radiation like cosmic lighthouses. We call them pulsars, and they tick across the universe with clock-like precision. Other times, the collapse goes further, creating a black hole. Here, gravity becomes so strong that not even light can escape. Space and time themselves warp, spiraling into an abyss. Black holes are the ultimate paradox, invisible yet shaping galaxies. Entire stars orbit them. Gas clouds swirl into their event horizons, and their violent mergers send ripples, gravitational waves, across the fabric of spacetime. But here's the twist: these violent deaths are not just endings. They are the universe's way of recycling itself. Supernovae scatter heavy elements, carbon, oxygen, iron, across space. These elements mix with dust clouds, forming new stars, planets, and eventually life. The iron in your blood, the calcium in your bones, the oxygen in your lungs, all of it was forged in the heart of a dying star. You are, quite literally, the child of cosmic explosions. Remember that fragile speck we started with. Earth exists because ancient stars died. Without their sacrifice, there would be no oceans, no mountains, no humans gazing up at the night sky. So yes, stars are monsters, colossal, violent, incomprehensible, but they are also creators. Their deaths seed the universe with the building blocks of life. Their explosions echo across billions of years, ensuring that even in destruction there is beauty. The next time you look up at the stars, remember this: you are looking at your ancestors. Their brilliance, their collapse, their sacrifice, all of it lives on in you. We are not just observers of the cosmos, we are part of it. Stardust, breathing, dreaming, and reaching back toward the stars that made us.